Good afternoon, good evening, and good morning. Greetings from Stanford University and welcome to the 27th AEC Global Teamwork Final Project Presentation Cyber Event. My name is Renate Fruchter, Founding Director of the PBL Lab and your host for the day. The PBL Lab is the home of the AEC Global Teamwork course I've been teaching since 1993 with partners worldwide. Our vision is to transform our students' tool set, skill set, and most importantly, mindset, moving from working in discipline silos to work as a single, cohesive, interdisciplinary team and develop fully integrated solutions. Our aim is to prepare the next generation leaders and change agents for the future workplace and challenges that they will encounter. What is unique about this class is that it brings together students, faculty, and industry mentors from 5 disciplines: architecture, structural and mechanical engineering, construction management, and life cycle financial management. Students learn to collaborate in globally distributed teams to virtually design university buildings, addressing local hazards such as earthquakes, hurricanes, flooding, local labor conditions. I have to say, this year has been a great pleasure to mentor and work with highly motivated, creative, and committed students from Stanford and 12 university partners worldwide. Given the unprecedented COVID-19 challenges and shelter in place, we are organizing this annual event in cyberspace rather than having everyone back at Stanford for a final great, engaging celebration. In preparation for this year's May 8th cyber event, we had to be creative as we are all geographically distributed over 8 time zones. For this purpose, each global student project team prepared a video story of their project evolution. These stories were reviewed and assessed by 30 industry mentors prior to the May 8th event. I have to say, we miss everyone back at Stanford for this event to celebrate the end of the AEC journey together. Nevertheless, we are really excited to see today at our May 8th final presentation Zoom live cyber event a great turnout of 89 participants that includes the global students and 57 industry and faculty mentors. Each team will present a TED-style project team pitch to give everyone an overview of their proposals, followed by a Q&A discussions of their concepts. But before we dive into very exciting student presentations, I want to extend a big thank you to our industry and faculty mentors, alumni, and owners and sponsors who so generously dedicated their time, attention, and knowledge to our AEC Global students. In collaboration with industry partners, we defined 3 challenges to further foster the students' creativity, focused on sustainability, specifically this year, resilience, integrating project delivery, focused on the question whether to industrialize or not to industrialize, as well as shared risk and reward, and technology innovation, focused on intelligent interoperability between models and disciplines. Winners will be announced at the end of the cyber event, May 8th. So don't forget to visit the PBL Lab Project Gallery website to find out who this year's winners are. Last but not least, a special thanks for the generous support of our technology industry partners that enable us to continue to develop new ways of working and learning by leveraging the latest emerging technologies like VR, virtual reality, AI, artificial intelligence, parametric modeling and optimization, and embed them in the students' new daily work practices that they experience in this global teamwork class. And with that, let's move on to the student presentations.
Thank you.
And hi, everyone. Welcome to this presentation from us, as Renate said, Team Island. My name is Rania, and I'm the architect of the team, joining from Aalborg University in Denmark.
Hello, everyone. My name is Simge. I'm studying at Stanford and originally from Turkey. I'm one of the construction managers of Team Island.
Hi, everyone. My name is Tian Long, and I'm also studying Stanford University, and I'm one of the structural engineers in the team.
Hello, everyone. My name is Jakob. I'm from the Technical University of Denmark, and I'm a construction manager on this team.
Hello, everyone. My name is Sebastian. I'm one of the structural engineers. I am studying in Bauhaus University in Germany.
Hello, everybody. I'm Nicholas. I'm the MEP engineer of Team Island, and I'm from ETH Zurich in Switzerland.
And this is our owner team, consisting of Paola, Hussein, Yuri, Miki, and of course, super owner Renate. We were asked to make a proposal for faculty in San Juan, the capital of the Caribbean island, Puerto Rico. There were some key elements of our design, and these were a tropical climate, outgoing and social people, being on an island, which meant very limited access to materials, and lastly, natural hazards in form of earthquakes and hurricanes, but also future risk of droughts. All this we had to embrace, and of course also the challenges coming with it. And from this, our big idea, which is embrace. We've designed a very open faculty with this large atrium in the center that would serve as a transition zone between the public and the private classrooms. But it would also serve to let light, air, and people move freely through the building. At the basement, we've implemented a living machine to invite the nature into a building and blur the lines between interior and exterior in this natural ventilated space. Our way to embrace the Puerto Ricans was to design an open and modern faculty that doesn't only serve the students going here, but also the greater public. And this is why we've located a cafe in the northern part of the building, very close to the main access and the road. So here you can get a coffee, and then you can go to the communal staircase and sit down and relax. From this communal staircase, you actually also have the view through the whole building, which creates a very strong connection between the entrance to the park on the other side, as you can see in these sections. My internet is slow, sorry. On the ground floor, this is the very public floor. People are invited to pass through this atrium, and on the journey through the atrium, they can see what's going on above them and underneath them through the whole building and get an idea of the life in the building. We've also invited the water into the building in form of a human-made waterfall running down the glazed elevator in the center of the building. Lastly, you can see to the right that we have these two large classrooms that are actually openable towards the park, so that the students can both join the lectures here from the interior and the exterior. And in general, it's been a very important factor for us to create spaces for people to thrive in. And this is why we thought that flexibility was a very important element. As you see, the smaller classrooms, for example, both offers spaces for collaboration and lectures and also workshops. As I've already mentioned, we also introduced a makerspace to foster creativity and innovation. Here we have a wood workshop and also a 3D lab. This is not only offering the students a place to try out prototypes, but also the general public for a place to join workshops, for example. Through the building around the atrium, we've offered a lot of different study spaces with different ambiences for the different preferences of the students. And here we can see a video of the elevator ride that's actually an event in itself.
Big atrium space also allows for strong buoyant airflow, which is very important since our most public open spaces are naturally ventilated. The enclosed workspaces, however, are mechanically ventilated and cooled. For our HVAC system, we use small integrated air handling units small facade integrated air handling units combined with ceiling fans. The system relies on an innovative comfort definition, high temperature and humidity, but with enhanced airspeed, which is introduced by the fans. As most of the users of the building are engineering students, we showcase the integrated building systems, energy data, and a ranking system to foster the conversation between them. For this, we created the concept of a frog race, with the goal to nudge the students and faculty members to be more sustainable in their usage of the building. Every day, each room will enter a race for the most energy efficient room, motivating the users to adapt their behavior to beat other rooms, for example, by utilizing less artificial light or wasting less water. We now want to explain you how our building becomes net water and energy positive. On top of the roof construction, we have our PV systems whose power is stored in Tesla batteries. While a part of the energy is used internally, we also provide energy to the power grid and to our integrated e-bike charging station. By this, we have a long-lasting impact on the greenhouse gas emissions of our whole surroundings. The collected rainwater, as well as other wastewater from our building, is recycled with the help of our living machine system for reusing it in non-potable usage, such as toilets. This allows us to serve other buildings with recycled water for the toilet systems as well, minimizing the water usage outside of our site. This water can also be used for landscaping, which will play a major part in future droughts. For example, in conservation of the rare species of frogs or trees that can be found on the site.
Now, knowing these spaces, structural engineers design a structure according to the technical standards, and that can withstand the natural hazards typical of the island. As shown in the video, first you can see the base isolation with isolated footings and retaining walls. Then, of the roof, you can see the parametric optimized bamboo roof trusses, and a structure being in the perimeter of the whole roof, which also functions as a parapet, protect the PV panel of the roof from the winds. It's important to highlight that with the application of base isolation, the building is proven to be fully operational after storm earthquakes by nonlinear time and story analysis. Being on an island, material procurement and shipping is always challenging. However, the team found a way to utilize local material, bamboo. Non-structural elements such as partition walls and entrance doors were designed with bamboo. Structural elements like roof truss was also parametric designed with bamboo to give warmth and brightness to the whole ambience. The animation at top right corner shows how using bamboo contrasts with normal concrete beams and bring light to the building. Now for the facade, we also embrace the local materials as hazard. For instance, the hurricanes are hot, sunny climate that Puerto Rico endures through creating space to include air handling units, louvers, and PV panels. The louver is made of bamboo to create a strong contrast to the visible concrete walls and to protect the glazing towards projectiles. Additionally, the sacrificial bamboo louvers are optimized for view and shading, and they can be prefabricated and easily assembled with instead reduce its cost in case of damage.
Since Puerto Rico is very prone to hurricane and earthquake, it's also important to address how the building deal with both of the hazards. So this slide is a summary of different strategies proposed by the team to allow the building to be operable when experiencing hurricane. Our main objective is to make repairs to some elements of the building if necessary in the easiest and the most economical way. Additionally, we seek our building to go beyond their educational purpose and play an integral role of post-traumatic stress management and recovery of a population affected by natural disaster as a relief site, supplying depots and communication center. So besides hurricane, earthquake is another major concern. Just on last Saturday, there was a magnitude 5.4 earthquake happening in Puerto Rico. Although earthquake is difficult to predict, safety education should be emphasized prior to earthquake events. During an earthquake, base isolation helps to minimize structural damage and remain fully operational after an earthquake. Then our building can help distributing necessary resources such as food, water, and electricity.
Now it's time to plan how we built our design. To better plan our site work, we used user simulation and virtually built our building. In this way, we could see bottlenecks and possible clashes that may occur on site and optimize our 4D schedule on LS by changing support relationship. On a critical day, such as peak workflow day, Fuzzer simulation helped us to coordinate construction crews and components shipment, which are essential for successful floor installation without colliding with on-site core wall construction. For example, we planned to install floor slabs in 3 zones to align installation with delivery frequency. Thanks to the Sustainable Target Value tool, our team was able to observe the evolution of greenhouse gas emissions, energy and water consumption of our building, generating different design ideas, such as implementing living machine, battery systems, bamboo as a construction element, helped us to reach all our targets very well. We use target value design to meet all our target cost, which is $11 million, throughout different design decisions. With PV panel systems, base isolation, and integrated facade system, we got closer to our target, but still we are under $1.5 million. Also, we believe that one of the key elements of successful construction is highly integrated design team from day one. We use the data we collected through our project to determine patterns and specific behaviors that help in optimizing our communication to foster this interdisciplinary data exchange and collaboration. As an example, we found common times of high responsiveness and started setting up office hours at exactly those times. Up to implementation of them, together with clear standards, protocols, team member preferences, and work profiles, our mutual trust and understanding grows, which led not only a more efficient collaboration, but also an overall stronger project. The tracking of information became easier because everything was stored in a central environment, meaning all decisions and discussions could be found easily. We observed the change in team dynamics in our virtual reality use as well. Throughout the project, we leveraged VR from weekly to daily use, and therefore, we became a more integrated team.
So, to summarize all the challenges, we are starting with the IT challenge, where our goal was to enhance our interdisciplinary team collaboration, while also optimizing our project, and we would integrate the future user in a responsive way. We achieved this by doing an extensive data analysis to allow for a better understanding of our team dynamics. This data was simultaneously used to keep track of our decision for more dynamic time-responsive risk analysis. Also, automated material takeoff allowed for faster interdisciplinary exchange of information, while we used generative design to optimize some solutions of our building. We also tried to integrate the future user by nudging them into a more responsible usage of water, energy, and by introducing a soft peer pressure with room frog race system. For the DPR challenge, our strategy was working towards a mindset for a shared risk and reward framework based on trust. By tracking and sharing information with all our stakeholders, trust is increased. This way we collaborate better and make joint decisions which are aligned to common goals. Furthermore, this helps us define design iteration evolved over time using a performance-driven prefabrication decision process, with indicators based on mitigating risk in a way to achieve shared rewards. To summarize our solutions to the resilience challenge, we would like to categorize it under 2 topics: the building during normal operation and then the extreme hazards events. The big challenges we faced during the normal operation were tackled with innovative approaches such as introducing bamboo as a construction material, but also achieving net positive water and energy system and the promotion of sustainable mobility. Furthermore, we aim to educate occupants through IT systems towards a more sustainable behavior, and by adding a workshop, will play a role for long-lasting impact on the community. Our challenges under extreme hazards such as hurricane and earthquakes, as well as future droughts, was addressed by the detailed design of the facade and structural systems, but also self-sufficient water and energy systems. Because of this, our building will shine after catastrophic events, as we aim for it to become fully operational for the community where we outsource food and other necessities. Coming to the end of this pitch, we would like to thank Renate and all our owners to help us develop the building and help us along the way. And a big thanks to all the mentors that have contributed to our project by sharing their knowledge and practices.
Thank you everyone for listening our presentation. We would love to have your questions and comments.
Thank you.
I hope you heard it. Thank you a lot for listening.
Thank you.
Thank you.